Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and I'm here with Victor. Before we dive in, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more listeners like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're continuing our journey through Chapter 1, Understanding Decentralization, and we'll be focusing on architectural decentralization.
Excellent, Victor. But before we jump in, I've got a quiz question for our listeners. Here it goes. Which of these is an example of an architecturally decentralized system? A. A traditional bank's computer network. B. The Internet. Or C. A single company's cloud server farm.
Ooh, that's a good one, Sheila. It really makes you think about the structure of these systems. I'm sure our listeners will have some interesting thoughts on this. It's not as straightforward as it might seem at first glance.
You're right, Victor. It does require some consideration. Now, to help our listeners understand today's topic better, could you start by explaining what we mean by architectural decentralization?
Certainly, architectural decentralization refers to how the physical components of a system are distributed. In an architecturally decentralized system, there's no single point of failure because the system's resources and responsibilities are spread across multiple nodes or locations.
I see. So, if I understand correctly, it's like having multiple libraries in different locations instead of one central library. Is that a fair analogy?
That's an excellent analogy, Sheila. Imagine a city with many small libraries spread throughout different neighborhoods instead of one large central library. If one library closes, people can still access books at the others. This distributed approach is similar to how architecturally decentralized systems work.
That makes sense. So, what are some of the key benefits of architectural decentralization?
Great question. The main benefits include increased fault tolerance, better scalability, and improved resistance to attacks. Because the system is distributed, if one part fails, the rest can continue functioning. It's also easier to add new nodes to handle increased load, and there's no single point that an attacker can target to bring down the entire system.
That sounds really advantageous. But I imagine there must be some challenges too. What are some of the difficulties in implementing an architecturally decentralized system?
You're absolutely right, Sheila. While there are significant benefits, there are also challenges. One of the main difficulties is maintaining consistency across all nodes. When you have data spread across multiple locations, ensuring that all copies are up to date and in sync can be complex. There's also the challenge of efficient communication between nodes, which can impact performance if not handled well.
I can see how that would be tricky. It reminds me of a common misunderstanding I've heard. Some people think that just because a system uses cloud technology, it's automatically decentralized. Is that accurate?
That's a great point to bring up, Sheila. It's a common misconception. While cloud systems can be architecturally decentralized, they aren't necessarily so. Many cloud services actually run on centralized infrastructure owned by a single company. True architectural decentralization involves distributing the system across multiple independent entities or locations.
Thanks for clarifying that, Victor. Now, could you give us an example of a real-world system that demonstrates architectural decentralization?
Certainly. One of the best examples is actually the Internet itself. The Internet is a vast network of interconnected computers and servers spread across the globe. There's no single central point controlling the entire system. If one part of the network goes down, the rest can still function, routing traffic through alternative paths.
That's fascinating. I never thought about the Internet that way before. Do you have any interesting facts about the history of architectural decentralization?
Actually, I do. The concept of architectural decentralization in computer networks was partly inspired by military communications. During the Cold War, the US Department of Defense wanted a communication system that could survive a nuclear attack. This led to the development of ARPANET, a precursor to the Internet, which was designed to be decentralized for resilience.
Wow, that's quite an origin story. It's amazing how those early ideas have shaped the systems we use today. Now, As we're wrapping up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The correct answer to our quiz is B, the Internet. As we discussed, the Internet is a prime example of an architecturally decentralized system, with its distributed network of computers and servers across the world.
Thank you, Victor. To summarize what we've learned today, architectural decentralization involves distributing a system's physical components across multiple locations or nodes. This approach offers benefits like increased fault tolerance, scalability, and security. However, it also presents challenges in maintaining consistency and efficient communication. The Internet is a prime example of an architecturally decentralized system.
Excellent summary, Sheila. I hope our listeners found this discussion enlightening. Remember, understanding these concepts is crucial as we continue to explore the world of decentralized applications.
Absolutely, Victor. And to our wonderful listeners, we'd love to hear from you. Visit crashcasts.com to join our Discord community where you can discuss today's topic and connect with other enthusiasts. If you're enjoying our content, please consider supporting us on Patreon. Every contribution helps us create more great content for you. Until next time, keep exploring the decentralized world.